Morning everybody, myself Chetan Lachure. I am the student of B.Sc third year and my group is Microbiology. So today I am presenting you a seminar. My topic is nuclear shell model. Let's start. So in my explanation, first of all I will introduce you to the nuclear shell model. Again I will explain about the postulates, experimental evidence of nuclear magic number, electric quadrupole movement, its advantages and limitation. Coming to the introduction, first the basic assumption of liquid drop model is that each nucleon in a nucleus interact only with its nearest neighbor, like a molecule in a liquid. That is, when you study the nuclear shell model, you see the nucleon which interacts with other nucleon are very close to each other. In a shell model, each nucleon interacts chiefly with general force field produced by all other nucleons. Means the nucleon react by a certain force which is called a general force field, which are produced by other nucleons. The atoms with 2, 10, 18, 36, 54 and 86 electrons have all their electron shell completely filled. In the same way, nuclei that have 2 at 20, 28, 50, 82 and 50 and 126 neutrons and protons are more abundant than other nuclei of similar mass number, suggesting their structures are more stable. That is, the atoms with 210, these numbers have the electron shell completely filled, and in the same way nuclei with 2810, 2820, 2850, 82 neutrons and protons are more abundant than other nuclei. Means these are found more abundant, hence they are more stable than the electron shell which is completely filled. It is also observed that nuclei having either the number of protons or number of neutrons, that is n is equal to a minus z, equal to one of the numbers, means their number should be equal to 2, 8, 20, 50, 82 and 126, and these are more stable than the other, and these numbers are called as magic numbers. Coming to the postulates of nuclear shell model, nucleons form subshell and shell within the nucleus. The shell within the nucleus get closed with a suitable number of nucleons, means the shell will be packed by the nucleons. The nucleon has a spin angular momentum as well as orbital angular momentum. This theory assumes that the LS coupling holds only for the very lightest nuclei, in which I values are necessarily small in their normal configuration. The heavier nuclei exhibit JJ coupling. This introduced that the small molecules are coupled by LS coupling and the heavier nuclei molecules exhibit JJ coupling. It is also assumed that nucleons move in its orbit within the nucleus independently of all other nucleons. Means the nucleus consists of nucleons which move in these orbits and they do not depend on other nucleons for this. The orbit is determined by potential energy function, which represents the average effect of all the interaction with other nucleons and is same for each particle. Means the potential energy will be same for each particle and it represents the interaction with other nucleons. Each nucleon is regarded as an independent particle and the interaction between nucleon is considered to be a small perturbation on the interaction between a nucleon and the potential field. So the nucleon is regarded as an independent particle and their interaction can be considered as small protrusion. There is a direct analogy between the theoretical treatment of a nucleus and an electron in an atom. Coming to next point is electron quadrupole movement. So what did the electron quadrupole movement means? It is a measure of how much nuclear charge distribution depart from sphericity. A spherical nucleus has no quadrupole moment, that is q is 0. One shaped like a prolate spheroid or egg shaped q is positive. an oblate or dish-shaped spheroid has Q negative. Nuclei of magic N and Z are found to have zero quadruple movement and hence they are spherical in nature. Means whether when there is spherical nature the Q is 0, when there is egg-shaped the Q is positive, and when there is disc-like spheroid the Q is negative. Shell model is an attempt to account for the existence of magic numbers and certain other nuclear properties in terms of nucleons behavior in a common force field. Neutrons and protons occupy separate sets of stats in a nucleus because protons interact electrically as well as through the specifically nuclear charge. That means the neutrons and protons occupy the separate sets in a nucleus. Now coming to the next point about experimental evidence of nuclear magic numbers. It has been experimentally observed that the nuclei for which N and Z are 2, 8 for helium and 60 are more stable than their neighbors. Means the N and Z which is mentioned, if the any atom has these numbers as their magic numbers, then they are more stable than any other neighboring atom. Stability is also related to natural abundance. It has been observed that from the experimental data that the nuclei having number of nucleons as a magic number are in abundance as compared to other nuclei in nature. Means the nuclei which consist of magic number and in compared to other nuclei which does not have magic number, so we can consider that the nuclei with magic numbers of nucleons can be more stable than any other. Some examples are mentioned. You can see that calcium, nitrogen, plumbum, all are abundant in nature. This is the relation between shell model and magic numbers. So zinc, which has 10 stable isotopes, more than any other element, and calcium has 6 isotopes. This indicates that the element with Z50 and Z20 are more than usually stable. Means the isotopes of tin is more, also the calcium has more isotopes than any other element, hence they are more stable. No more than 5 isotopes occur in nature for any except N where there are 7. Neutron numbers of 80 to 50 which indicate particular stability. Means when they have N is equals to 50 and N is equals to 82, if N is 50 then there will be 6 isotopes, if N is 82 then there will be 7 isotopes, and this gives their particular stability. The doubly magic nuclei N and Z both magic in helium and in case of calcium also and plumbum, they are particularly tight in bond. Means their bond is very compact as compared to other elements, and the binding energy of the next neutron and proton after magic number, they are also very small. Now coming to the advantages of shell model. It explains the magic number as we studied earlier. Also it explains the magnetic movement of some nuclei nicely. It also explains successfully the ground state spin. This is included in the postulates. It explains the great stability and high binding energy. We can also understand the element's stability and its binding energy by the shell model. It also explains the phenomenon of nuclear isomerism. We can count the number of isotopes a particular element formed, and it also gives the stability of the element. Now coming towards the limitations of shell model. So what are its limitations? It failed to explain the stability of 4 stable nuclei: helium, lithium, boron and nitrogen. Means these 4 elements and their stability cannot be explained by shell model. It does not predict correct values of nuclear spin for certain nuclei. Also, the nuclear spin value given by a shell model is not perfectly correct. The quadrupole moment calculated using this molecule is also calculating using this model is also not in good agreement. Means we can get the quadrupole moment by this method, but the answer we get, we cannot say that this will be a sure quadrupole movement. The magnetic moment is also shows some deviation from observed values. Means the observed values performed by experiment and the magnetic moment calculated using shell model by formula, also they say, also there is some deviation in their values. So this is all about shell model. Today I explain you. In this way we can get the advantages, postulates, limitations of shell model explained in my today's seminar. Thank you.